Welcome back to another AP Pre-Calculus video. Today we'll be going over a topic 2.12 of log function manipulation. Alright, so let's get started. So for each of the following, write an equivalent expression using a single log. So as we know from the 2.12 notes, we know that if it shows an addition in the equation, so like that one has addition, this one has addition, that means that we'll be multiplying. So that was the product property. When two log graphs are added to each other, then we multiply the numbers being multiplied with their corresponding log. So basically we keep these the same. It's kind of like 5x plus 10x. We're only adding these, and then we're keeping the variable the same. Log is basically the variable. Log 3. They have the same log, so we can add them. Or in our case, yeah, we're adding them, and then we're multiplying these two numbers since it's an addition. So then our answer would be log 3. We keep that the same. And then we have 4 multiplied by z right here. 4 and z. So 4z, and that's our answer. So that's basically multiplication. So yeah, just think of it, addition, multiplication, they have pretty similar signs. And then when we go to number 2, we see that it's a subtraction sign right here. And so that corresponds to a division sign. That's the division sign, or it's just a fraction. Now this one is the quotient property, where it's a subtraction sign, so that means that it's division. So, right, we keep these the same, and there's a subtraction, so that means that we're going to be dividing this number and this number. Ln, we keep that the same. And then the number being multiplied with ln is going to be x over w, which is x divided by w. So that's our answer. So our next problem, we see we have a subtraction sign here and a subtraction sign. That means we're dividing twice. So basically, we read from left to right. So we start from the left, so we want to divide this number and this number first. So let's go ahead and write our log, which stays the same. Like, you keep the denominator the same when subtracting or adding fractions. And then we have 3 over x, and we want to bring this back, or bring that down, because we haven't done that yet. So minus log. Okay, so that means that we're dividing this number and this number. So we can do that there. So it's 3 over x divided by 5, which we can change it. So 5 can also be 5 over 1. And now we can change it to 3 over x multiplied by 1 over 5. We switch this fraction around. That's going to give us 3 over 5x. And so this is our answer after dividing 3 divided by x. And then the answer to that gets divided by 5. And then we get this right here. And so that means our answer is going to be log 10. Bring this down. And then this right here. So 3 over 5x. So now moving on to number 4. Okay, we have addition right there. Oh, but we also see that we have a number in front of the log. We don't want that. Remember, when we are adding and subtracting these, we're only changing the number after the log. So when we see if we have a number in front of the log, we have to do something. That would be the power property. We want to change so that everything is after the log. Nothing should be before. All right. So the power property tells us that when there's a number in front, it's going to be the same thing as moving that number that was in the front to be the exponent of this number. So basically, if I erase what I just wrote, 3 can be moved to be the exponent of x. So if I rewrite this equation, log 4x, so that 3 was moved to here. So now it's x to the power of 3. So now when we look at what we are multiplying, since this is an addition problem, we're multiplying 6 times x to the power of 3. So it's going to be log 4 times 6x cubed. So that's our answer. So now moving on to the next problem. We have a mix of addition here and subtraction. But we see we have numbers in front of the log. And also ln just means log of e. Just to clear that up. So now we want to move this 5 over here and this 2 here. So if I rewrite this, that's x to the power of 5 plus ln y to the power of 2 minus ln w. So now we have addition first. So multiply these two. So ln x 5y2. And now bring what we haven't done down. This right here. This is subtraction, so we need to divide this w. So we're just dividing this w. And so our answer is going to be x to the power of 5 times y to the power of 2 over w. All over w. So that's our answer. So now number 6 looks kind of the same as number 5. So we got to bring all of those numbers to the exponent of their numbers after the log. So log 2 to the power of x minus log x to the power of 3 minus log y to the power of 1/2. And so now let's divide these two first. So log 2 to the power of x over x cubed. Hopefully you can tell that's a 3. Minus log y over 1/2. And if we remember, a number to the power of a fraction that's positive is basically just rooting that number based on the denominator, because the denominator changes to the index of the root. So 2, so that means we're just squaring y. This number is equivalent to this. So we can change that. So we're just dividing 2x over x cubed divided by the square root of y, which we can change to this multiplied by, because we add a 1 on here, 1 over square root of y. So that's going to give us 2x on the top and x cubed times square root of y at the bottom. And that would be our answer, but make sure we have a log in front. So I'm just going to put our answer up there. Log this and this exact thing. And that's our answer. So now moving on to these longer problems, but they might be a little easier since we have choices to choose from. So, which our following expression is equivalent to log of 5. And this expression right here, where y and z are positive constants. Okay, so we know that this is division right here. So we know that it must be subtraction, and we see that there's exponents there. It could be in the original equation, but that probably means that they moved it. So they had the exponent, they got it from the number before the log. That's probably what happened. So we can look at the answer choices. So if we look at A right here, it looks like 3, it's adding first, so it's 3 multiplied by 4y. We already know that's wrong because there's no 4y here, so we can cross off A. If we look at B, we have 3 on its own. We're gonna do that later when we change a number on its own. Basically, everything that we add, it needs to have a log. So just change 3 into like an individual a number it's on its own, a constant, to a log. We have to have it change it to log, right, of the same log. So this for example has log 5. So yeah, log 5, we can use the matching base property, and because we used log 5, I'm gonna use this number right here should match this number so it can equal to 1, but I need this to equal to 3, right? So we just multiply this by 3, which also means that I'm multiplying this by 3, but I'm actually not multiplying this number by 3. I'm actually going to it's going to be to the power of 3 instead of multiplying, because like, I don't know, you just kind of have to remember that. So 5 to the power of 3, that gives us 125, and now it equals to 3. So now we just changed 3 into the equation where it uses log of 5. which B is clearly not the answer then, because 125 is nowhere in this equation. I mean, everything else here is correct. We had this 4 moved here, and this 2 moved here, yeah, but log of 5, 125, that's wrong, so cross off B. Now we have C here. 3 times, we move this 4 here, 4, and then 2 here. So this one looks good. It's 3, and then we multiply by 4y, or y to the power of 4. Then we divide by z to the power of 2. And this right here matches what's inside right there. So that looks good. We're not going to cross off C. And then this right here is division. This is completely wrong. We can't change a division into a division. And these two are being multiplied to each other. Yeah. D is just wrong. So yeah, our answer is C. Which are following expressions is equivalent to this. So we see these are being divided. So subtraction. Okay, so 2 is on its own in A. So if we change that here to change it using ln, which is log of E, we can just do E is equal to 1. But now we want that 1 to be 2, so we multiply by 2. We're multiplying this by 2, but actually we have to remember to actually exponent it, so e to the power of 2. So it's going to be e, or log of e times e to the power of 2, and that's going to give us 2. So this right here is this one. So we can see that it's addition. So we have e2 right here added to ln 5. So far it looks good. 5 times, or I guess we can do e squared times 5, but it's the same thing as 5 times e squared. And then we're subtracting here, so that's dividing. Move this number to the front right here, and that's the exponent of 1 half, which is the same thing as square root of x. So that actually looks correct. A, this is literally equivalent to that. So A looks correct so far. We're not going to cross that off. Okay, so for B, that's 2, and so that gives us 25 divided by square root of x. That's wrong. There's no e in the equation. So cross off B, we have 2 right there. So we know 2 is equal to this. So use that. E squared times 5 divided by, we move 2 there, x squared. X squared is the opposite of square root of x, so that C is also wrong. And then now we have D here, move 2 up there, that's 5 squared, which is 25 over x over 2, or x to the power of 2, and that's wrong too. So our answer is A. Hopefully you got that, because that was pretty fast. Now we have number 9 here, which the following is equivalent to this, where x and y are positive constants. This number we have to move here, and move this number to here, and move this number to here too. So let's rewrite that. I'm going to rewrite it up here, log x to the power of 3 minus log y to the power of 2 plus log 16 to the power of 1/2. So this right here is the same thing as square root of 16, which gives us 4. I can erase that, but I'm just going to keep that and know that this is 4 when we are multiplying or adding it, or multiplying or dividing it. So we have minus here, so that's division. So I'm going to write it down here. X cubed divided by y squared. And then we have addition here, so that would be multiplied by 4. So we can do that. So that gives us 4 times x to the power of 3 over y squared. So this number right here should be in the parentheses, and then on the outside it's just going to be log, because log stays the same. So we look at that in the answer choices. Let's see here. This one has 4 and x cubed being added. That's wrong. They should be multiplied, so that's wrong. 4 is at the bottom here. That's wrong. This looks correct so far. And D has the number 8 in it, which is wrong. So our answer is C. So now number 10, which of the following expression is equivalent to log of 5 times x? Alright, so this kind, so also in the notes, we learned change of base property. I think there's a way where you can do math to solve this problem. I'll put a screenshot, but you can also do it by remembering the change of base property, where basically we have a certain expression and we need it equivalent to another expression, but it has a different log base. So changing the base property. So there's a formula here where we have our certain expression, and then it will change into this. So basically, we have our expression here, which is this, and then it will be equivalent to this right here, where we did change the base. Usually it's a base of 10 or base of e. And so right now we have a base of 5, and if we look at all of our answer choices here, they all have, they're not showing anything, which means that it's a base of 10. Hopefully you know that. And so that means that our A is 10, and if we look back here, B and X, that we'll know that because of what we're given here. So 5 is B, and looks like X is X, so the 5 will go to the bottom, and the X right here, or our X, goes to the top number. So we need to look for an equation that will look like log, and we checked earlier, it's all using 10, so I'm going to write 10 just so you know, multiplied by, at the bottom is B, and our B is 5, and at the top is X, and our X is X. So we need to look for an expression that looks like that. So it's not A. B is close, but 5 and X is switched, so that's wrong. Looks like it's C, and D is subtracting it, so that's wrong. So our answer is C. So number 11 looks like the same kind of problem as number 10. Straight off the bat, let's look at our answer choices here. We see that this one right here, it has 2 different kinds of bases, so we already know that's wrong because the base should be the same when we're changing the base. This right here, these two have the same base, but they have different bases. So remember, this right here is B, and this right here is X. And if we remember, let's ignore the kind of base we have right now because we don't know, right? But we know that X goes on the top and B goes on the bottom. If we replace that with what we have, 3 should be at the bottom and 7 should be at the top. In our case, C does not do that. 3 is at the top and 7 is at the bottom, so C is wrong. And then if we look at A, that's no division, so that's wrong. So our answer is D. And it looks like our A right here is E. Our base is E. So now we have this problem here. So we have f of x here, and then which of the following is equivalent to f of w minus 3 times f of z? And those are positive constants. Okay, so we don't know f of w and we don't know f of z. Well, we just want to know what's equivalent to this right here. So we know we're using f here. So basically w is just a number and z is just a number replacing the x. So it's basically log 6 replacing the x, so we're just going to put w minus 3 and then multiplied by log of 6 times z, which is replacing the x, so we'll put z there. Okay, so 3 right here is being multiplied with this log, so that must mean that if we erase this multiplication sign, let's just bring that 3 closer there, that must means that it's going to be the power property where we're moving that 3 to z. So I'm going to rewrite it down here, log 6, so I'm basically just taking away those parentheses, minus log of 6 and z to the power of 3. So now we see that it's just subtraction, so now we're just going to divide. We're going to divide w and z to the power of 3, so w divided by z to the power of 3, and that's in the parentheses multiplied by log of 6. So that should be our answer, and if we find that there, this is multiplication, so e is wrong, a is multiplication, so a is wrong, W divided by Z of 3. Looks like B is correct so far. D is Z times 3. That's wrong. And then C has both numbers, W and Z to the power of 3, which is, it has W divided by Z to the power of 3. That's wrong. So our answer is B. So now, number 13, we have G of X, which is equal to log of 4 of X. So which of the following about the graphs of F and G is correct? So it looks like G of X is just a transformation of F of X, because we see F of X is equal to this right here. This is very similar, except it just has 4. G of X just has 4 in front of the X. So that's probably a transformation. We know if it's in the inside, then it's a horizontal transformation. We know that it's 1 over B times X. So that means that, because we know that's the formula of the transformation that's being multiplied by X. We know ours is 4, so we're going to equal this to 4. I erased that X. I don't think I need that X. But 1 over B is equal to 4, right? So so basically we can move this B to this side, so multiply B both sides. So 1 is equal to 4B, and just divide that. So B is equal to 1 over 4. That means that our horizontal dilation, our transformation is 1 over 4. So if we look at that, only B has a factor of 1 over 4, so then our answer is B. So now number 14, let H of X equal that, and K of X is equal to this. So it looks like K of X is a transformation of H of X just by 8. So it looks like it would be the same thing, 1 over 8. Okay, but it's actually not in the answer choices. So we didn't do it wrong, it looks like, but it looks like it's tricking us here. So there's a possibility that H of X is a transformation of K of X, because it looks like K of X cannot be a transformation of H of X. So, also what I'm saying that might confuse you, I don't know. Let's say H of X is the first graph, the original graph, and the copy was K of X. But clearly it's not a copy, because the first graph, H of X, has to be multiplied by 1 over 8 to get this, and none of the answer choices has 1 over 8, so clearly it looks like K of X is the original one and H of X is the copy. So we see here it's 8, so we know this right here, that's the transformation of K of X, which led to another transformation that is what happened after doing 1 over B. So 1 over B is equal to 8x, right? So we want to find out what B was that got us this, and we know that's 1 over 8, like we did last time. Alright, from our knowledge of the last question, we know that we got this from having X being multiplied by 1 over 8. Alright, so it was basically, because it's 1 over B, so it's just 1 over 8, which equals 8, which got us this. Okay, so then we know it's 1 over 8 here. B is 1 over 8 here. This is 1, so it must have been 1 over 1 times X, right? Okay, so that means B became 1 in H of X. So that means that the B here is 1 over 8, right? So 1 over 8 times what gives us 1? What changed 1 over 8? The original B to be 1. Okay, so we can change the question mark to an X there. So we can divide both sides by 1 over 8. So X is equal to 1 over 8, which is the same thing as 1 times 8 over 1. We can do that. So it's just 8 over 1. Okay. So that gives us 8. So it looks like we had a horizontal dilation of 8 with K of X to give us H of X. So if we look in our answer choices, it should have said that like the graph of K had a horizontal dilation to get graph of H of X, which will be the same thing as saying the graph of H of X is a horizontal dilation of K of X. So if we look here, the graph A says the graph of K is a horizontal dilation of the graph of h by a factor of 8. The factor is correct, but it's saying that k is the image of h, or k is a copy of h, which is wrong. The graph of k is not a dilation of x, or h. H is a dilation of k. And B says the graph of h is a horizontal dilation of the graph of k by a factor of 8. That looks correct. So let's cross off A. We're going to circle B for now. Now C and D says -8. It's a vertical translation. That's wrong. Vertical would mean that the number is on the outside. And in this case, a translation, so it's addition or subtraction by -8. So it'd be like -8 on the outside here. So it's not C or D, and our answer is B. Hopefully that made sense. So basically we're trying to find B of each equation, since we know that dilation of on the inside, which is a horizontal dilation, is gonna be 1 over B. So we were trying to find B and see what happened to B to make it 1, which was the B on h of x. So yeah. And that was topic 2.12, and thank you so much for watching.